Like,
Okay, I'd like to call to order the St. John Sanitary District meeting for Wednesday, January 15th. We'll start out with the pledge to the flag.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Next item is roll call. Kill,
Here.
Sims,
here,
Gruhl is absent, Schaefer here. Hatfield.
Here.
Okay. We have election of officers tonight for the 2025, for year 2025. The first is I'll open up nominations for president for the sanitary district.
I will nominate John Schaefer as president of the sanitary district.
I accept. Any other nominations? Nominations are closed. Look for a motion to approve John Schaefer as the St. John Sanitary District President.
I'll make that motion.
Motion made. Second?
I'll second.
Motion made and second. All those in favor say aye.
Aye.
Motion approved. Nominations for vice president are now open. Looking for a nomination for vice president.
I'll nominate Kyle Kill.
I'll accept.
Any other nominations? All right, nominations are closed. Looking for a motion to approve Mr. Kill as the vice president for the St. John Sanitary District.
So moved.
Second.
Motion made and second. All those in favor say aye.
Aye.
Motion approved. Approval of minutes for December 18th, 2024 for the regular meeting. Looking for a motion to approve those minutes.
So moved.
I'll second.
Motion made and second to approve the December 18th, 2024 regular meeting minutes. Under the question, all those in favor say aye.
Aye.
Motion approved. Item number 6, Lantern Woods inflow and infiltration presentation by Robinson Engineering.
Thank you, Mr. President. I brought Robinson's I&I department manager, him and his staff, prepared the reports, did the inspections, looked at the flows, and he is here to answer your questions and tell you how bad the area is or isn't.
Floor is yours.
Good evening. Thanks for having me here tonight. My name is Joe Sullivan. I'm the I&I department manager for Robinson Engineering. So just wanted to kind of give a overview of the two reports that we're presenting tonight. We'll start first with the Town of St. John 2024 Sanitary Sewer Evaluation Study, which included the manhole inspections and smoke testing. We look at page 1 of the report. We conducted 109 manhole inspections in the west zone area and also roughly 25,000 feet of smoke testing in that area. The work was done in April and May of 2024 for the manhole inspections, which is the right time of year to do it. It's in the spring when conditions are wet. You've got manholes that are leaking at that time. And then the smoke testing was conducted in July, which is the dry time of year, which you're going to find the most defects when the ground is dry and able to allow that smoke to come up through the ground. So that's a little background on the testing that was done. Of the 109 manholes, I'm on page 2. We found 89 manhole defects, and those were in 79 manholes. You can see the photos here. We kind of have a summary of each manhole defect type that was found. So 14 were manhole cover instances where there was either a pick hole or a poorly fitting lid that was allowing inflow into the system. 33 manholes were found to have poor frame seals. That's a pretty typical defect on manholes in our area because the freeze and thaw cycles that we go through, that's the top portion that's, getting, the ground is getting frozen, permafrost every year, then it's thawing out. So that's typical to find defects in your manholes in that portion, at the top portion of the manhole. 4 of them were identified with cracks or cone leaks. On to the next page, 6 had wall bench joint leaks. 2 of them had poor pipe seals identified where water was gushing in along the pipe seals. And then some leaks were found along the bench channel, as well as some roots coming into the manholes as well. There's a summary of the defects found, of the 89 defects found on page 4 of the report. That's kind of what we just went through. And then if we flip to page 5, all of those defects have a remedy associated with those. So we've put together the recommendations for repairs for those 79 manholes. And those repairs are including curtain grouting of the manholes, which are pumping grout through the manhole walls to the outside of the structure to eliminate those infiltration sources. There's grouting pipe seals, installing new frames and lids, installing just lids. There's some manholes identified for some heavy cleaning, just maintenance items there, and then patching wall joints, cementitious coatings, which are a structural repair to the manhole, and then sealing and adjusting the manhole frame. The total estimate for that work, construction total, is about $210,000. With engineering services would be about $230,000. So that kind of covers the manhole inspection summary. Any questions for that first part?
During the smoke testing, did you find any direct connections between the sanitary and storm sewer?
We did not. We did not find any cross connections between those two systems, but we can just jump right into the smoke testing portion next. We did 25,000 feet of smoke testing. We looked for anywhere that the smoke was coming up through the ground. That was documented with a digital photo, with a GPS point. We had a dashboard that was sent to the town so that you guys could log in and see that data as it was being collected real time. But if we jump to page 6 of this report, you see there were only 49 defects identified. My crew is very well versed at finding defects, so the fact that they didn't find more than 49 defects means there's likely not more than 49 defects identifiable with smoke testing. And talking it over with sorry, I didn't catch your name again, Mike. There's a suspect that there could be some sump pumps in the area that are connected that are also contributing flow. You don't often find the sump pumps with smoke testing because people's sumps are in their basements, they're connected, they've got a check valve on the sump pump, so the smoke will either be blocked from going in there, or if it is identified in the home, we'll offer our services to come in and help identify the source, but a lot of times nobody wants a stranger coming into their home and walking around their basement, especially if they have a known sump pump connection to the sewer, then they especially don't want us to come in and check that out for them. So,
Okay. Mike, a question for you. Being that this is probably one of the oldest parts of town, I think the Lantern Woods area here, do you know off the top of your head, is there do you think if there are sump pumps in that area, do you think they're connected to the storm sewer? Or do you think that they may be directly connected to the sanitary? it's internal, on the inside of the home.
It's really hard to tell without getting in and doing a full inspection. We really don't know. It's just my assumption, especially after seeing this data, how you said like 49 places, really not significant for the amount of flow that goes through that lift station.
Right. Okay.
Now, in my experience, the sump pumps are almost always connected within the home. So you would find that through a house-to-house survey or building inspections, actually knocking on the doors and going in and looking in the basements at the sump pumps.
Right. And I would say the same in the older section. I know the newer subdivisions there's a different code out. I think it's
Sure.
two separate. You have to have your sump pump connected, to the sanitary or overland. Or not to the sanitary.
storm.
To the storm.
Right.
Or overland.
Right.
So,
Was previous code at the time that subdivision Lantern Woods was built differing?
I would
In a
think
way
it would
that's
have been.
Yeah, connected
Because
to
it's
sanitary
an
rather
older
than storm?
subdivision. That was probably built in the,
70s, I would say. Yeah, back then, they thought that plugging some of the sump pumps into the sanitary sewer was a good idea to keep them clean.
right.
Disinfect them, keep flow, and it turns out not so much a good idea.
Have we ever had a flow test of Lantern Woods even like 20 years ago or longer, or is this the only time we've ever had this done?
I'm not aware of any other tests. There is a report that Public Works does every month with, how the meter on the lift station is running, but not,
There was some flow testing conducted in 2006.
Because I'm just thinking here, if, obviously the amount of rainfall, it probably isn't going to change between now and then. So the sump pumps haven't changed either. So the differing, between that flow versus this flow would just be from the manhole defects, and then we could figure out how much is coming just from surface level things rather than the sump pumps, right?
Yeah, and we'll get into the flow report next, but basically jumping ahead a little bit, we didn't see a large response from the rainfall during the flow monitoring study. We did see some influence from groundwater out there. So groundwater, you're getting influence 365 days a year. Rainfall is dependent on the rain, that rainfall occurring. But we'll get into that next. And we did, we felt pretty confident that the defects we identified during the manhole inspections and smoke testing matched pretty closely with the flows that were measured in the flow monitoring study as well.
Gotcha.
So a summary of those defects can be found in the appendices, but here's just a recap. So there were some clean out caps that were either broken or damaged that were found to be emitting smoke. 3 clean out risers, so that's the vertical portion of the clean out that was emitting smoke. 1 external sump, so this is actually an indication where inside the home, the sump is likely got a diverter valve. You can switch it to go outside, or you can switch it to go to the sewer. You can see it's kind of a small photo here on page 7 in the bottom right, but that's the discharge hose coming from the sump pump connection in the wall. So that the fact that there's smoke coming out of there tells me that's likely one of those homes that has a sump pump connection to the sanitary, and that valve is just not blocking all the smoke. So we're seeing the smoke going, probably to, from the sewer through that check valve and through the bypass out to the alternate discharge point there.
Right. They probably did a winter, summer.
Yeah, absolutely.
Summertime, it goes into the sanit.
I mean, in theory, it's great,
Wintertime, it goes into the
Summertime, you water the garden, and wintertime, you send it to the sewer, or, you don't want a puddle, you send it. So I've seen a lot of those. I've done a lot of building inspections in my career, and oftentimes when there's some pumps in a neighborhood, they have those type of diversion valves, set up on the inside. Page 8, we did find 21 frame seals, so that corresponds very well to the frame seal defects that were identified during manhole inspection, so there's some overlap there. Gasket seal covers and pick hole covers, 12 of those identified again during smoke testing, And those are easy sources that, the town can just order new covers and swap those out. Make sure to take measurements. We've got the measurements from our data to order the right cover sizes for those. And that's a quick fix that you can chip away at some of the inflow out there. 3 service laterals were identified. If you see that service lateral there on page 8, that's a huge gaping hole that somebody put a piece of plywood over. So that's a big source right there. That's one that can be looked at. Is that something that the town can fix, or is that something that the private sector resident would need to address? But that's a big source right there. Anytime you find a big sinkhole smoking, that's going to take a lot of
I
water.
think that one may have been repaired. That's on 93rd. That house that sits way up on the hill there, it's got that real steep driveway.
Yeah, it's 13440 West 93rd Avenue.
Yeah, that may have been repaired already.
Okay.
Okay.
So that kind of recaps the smoke testing defects that were found. If you jump ahead to page 9, overall there were 49 defects. We summarized those and then put a cost together for the associated repairs. And so the cost for the associated repairs is roughly $82,000. With design and construction engineering services, that is, roughly 98 or 100,000.
And on that, your estimate for the frame seal and manhole, are you looking like a chimney seal, internal chimney seal?
The frame seals, we generally recommend pulling it all apart. The internal chimney seals, they look nice when they're first installed, but they really don't work over time.
For an exterior seal?
Yeah,
on
so
that?
pull apart all the rings, the adjustment, and then you put it all back together with new bituminous mastic between each joint, the external chimney seal around it, and that we found that to be the most effective way to deal with it.
Mac wrap.
Mac wrap is one. Yeah, that's typically used for the joints on manholes, but they do have a product that would be available for the external as well.
Okay.
I just have one question. So many of these were found on public manholes and some are on private property,
We identified one as a private manhole.
right? And then on the previous page, like the external sump, that's on private.
Yes.
What is our recourse gaining access to these ones on private property? Can the property owner refuse and not cooperate? Is it a code issue?
We'd have to look to see what the ordinance actually says.
Yeah,
If,
just curious, because we need to fix it.
if it's code violation, you can send letters, ask them to comply with the code and things like that.
Okay,
Some ordinances have it where the municipality has the right to go on the property, inspect services or things like that. We actually have to look to see what the ordinance says and what that would be, and then,
yeah, because I see on the cost breakdown, it includes some of these that are on private property.
Right.
So,
and some ordinances even allow internal inspections
right,
where the municipality is allowed or can request to go in and make an inspection, like for a sump pump inspection, to see how it's tied in. But that gets a little bit more
we'd have to research that then.
correct.
Okay,
Yeah, most likely it's in your ordinance to do those inspections and then, send those notices of violation for corrections to those.
your experience, it's not a big issue.
In my experience, towns can do it in, they kind of do it in a tiered approach where the first phase, you're having them correct things that are pretty low-cost items. So those would include like downspouts, window well drains, clean out cap covers. Usually all of those can be $200 or less. If you're hiring a plumber, maybe you're paying $300 to do something like that. But those are the low-cost items. Then you kind of move into the more costly items, which would be sump pumps, disconnecting those on the internal side of the homes. That's, you get good bang for the buck doing that. Phase 3 would be, hey, we're looking at your service laterals. We're looking at any stairwell drains or area drains that were connected that would have to be rerouted to the storm sewer. Those can be a little bit more costly. So we've seen it generally done in like a 3-phase approach. And oftentimes the laterals or the most costly things are saved till the very end, till the town system is completely rehabilitated, and it's like, you can evaluate at that point, is it even worth going after those defects, or have we done enough to seal up the system?
But many of those repairs that you just spoke about would be the homeowner's expense, not
Yes,
ours.
correct.
So there might be some pushback.
Depending on your ordinance. I haven't read through your full ordinance, but yeah, if your ordinance says that the homeowner, owns all the way up to the connection point on the main, then it would be, upon them to make those repairs.
Makes sense.
Yeah. And we did break it down by public sector and private sector costs. So the costs that I just mentioned were just the public sector defects found. And then on page 10, we summarized the private sector defect costs. And those were roughly $50,000, $65,000 with engineering assistance to provide letters and a private sector disconnection program type program. Yeah, so we look at all of these things from a cost-effective standpoint. Is it worthwhile to spend the dollars to remove those I&I sources, or is it cheaper to just transport and treat it, or expand the wastewater plant? So the majority of what we found is cost-effective to repair. So that's just kind of a little analysis that we do internally when we're looking at these defects. The recommendations out of this report are: 1, approve a manhole rehabilitation package, a bid package to do that repair work. 2 would be to address the cover issues, which can probably be done by the town internally, just swapping out those lids. And then 3 is kind of what we've been discussing, is the private sector disconnection programs, which could then, in later stages lead to lateral TV inspections, performing building inspections on those homes that were suspect to have sump pumps, and then, private sector clean-out repairs for the riser section. So that kind of summarizes that report. There's a lot of maps that show all the locations of the manholes and the smoke testing defects that were found, and a lot of photos. So we've got photos for each manhole, photos for each smoke testing defect. So, but that's kind of a recap of that first project.
Okay.
Jumping back to page 9 real quick.
Yeah.
As far as the summary for the public sector, some of that work to be done, and Mike, correct me if I'm wrong, some of the stuff with the frame seals and taking them apart and cleaning them up and putting some wrap on them, is that some of the stuff Public Works could do? Absolutely. Okay.
Yeah.
I mean, what would that design engineering and construction engineering cost cover for that?
Well, Public Works was doing it, it would be pretty much zero. Aside from if you wanted us to come out or, kind of do a training program. I've done that with other villages where they're going to do that work in-house, and we've just had like a kickoff meeting to kind of go over the materials list and go over the procedures and things like that, so that work could be conducted in-house.
Okay.
So maybe not zero for the engineering fee, but it would be much less than that. These are fees typical of putting together a bid package for providing bid documents to put that work out for bid.
Okay.
Thank you.
You're welcome. Okay, moving on to the 2024 flow monitoring project that was done for Lantern Wood. So we had 3 flow monitors installed for a period of 90 days. And what we hoped for the flow monitoring study was to measure both the wet weather flow and the dry weather flow components, so we could see what the baseline flows were and then what the flows were when it jumped up during wet weather. So those locations are shown on page 1, and then there's a basin map shown with the colored polygons on page 2. So basins 1 and 3 flowed to the Lantern Woods lift station, and basin 2 flowed to, what's the name of that other lift station there, Dave? Which one?
Shilton Hills?
Chilton Hills.
Okay. So they were, even though those were kind of, it overlapped pretty well with the West Zone SSCS program, these basin delineations were slightly different just based on the configurations of the piping out there. Yeah, page 3 shows a good schematic of those flow meters. So again, we looked at the dry weather analysis. If you flip to page 4, we've got a graphic up there on the top of the page that shows the diurnal curve for one of the flow meters. Basically, what we're looking at is the weekday and weekend flow for that flow meter site. On the left-hand side of the graph, you see that the line is much lower. That's like midnight hours till about 3, 4, 5 in the morning when people are sleeping. They're not using much water. People are waking up around 5:30 and 6. They're starting to shower. You can see the blue line, which is the weekend. It trails by about an hour for the time the flow starts to increase on the weekends, because everyone wants to sleep in for an hour later on the weekends. I know I do. But then, as people finish using the water, they go to work, there's a peak, it starts to subside, it comes down to another valley, a low point around 3 p.m., and then as people get home from work, that flow starts to increase again and drops back down toward midnight. So that's just a graphic showing the actual diurnal pattern for one of the flow meters out there. I mentioned groundwater infiltration. So we had an analysis done looking at the groundwater component. So basically, if you look at the first graph up top, you see there's the trough at that midnight hour. It's still not at 0. So there's still some flow that's always getting into your system from groundwater. And this next graphic at the bottom of page 4 shows the percent of groundwater to the average dry weather flow. So anything between 20 and 40 is considered marginal. Anything over 40 is considered significant. So basins 1 and 2 were over that 40% margin. Basin 3 was lower. So jumping back to page 2, it was 1 and 2. So the western half of that map had pretty high groundwater. The eastern half, not as much groundwater infiltration.
I think that's a little bit interesting. I want to say, 2 is probably the newest part, and 3 is the older.
Maybe older.
Yeah. Interesting.
Yeah, I mean, it's,
Mike, I'm going to throw a question. I don't know if you, once again, I'm asking you off the top of your head. So in basin number 2, if you look on page 2, basin number 2, that's the bluish one there. Do you know what the depth of those sewers are on an average? Are they deep or? So I just wanted
Not
to pick it up.
100% sure. I know the actual lift station itself is, I believe that one's 26 feet.
it's not in the manhole report, but we do have it in our collected data.
Just wonder if we have high water tables over there, which if the sewer's deeper, it's probably going to pick up that.
Absolutely. And, age doesn't really matter. It matters, construction methods, construction type. If they were putting in,
If they're top ends or-
SDR 35 and it was deep, that pipe can flex. And if you've got pipe that's flexing at the manhole wall, certainly flow could get in at those pipe seals as well.
Right.
Yeah, once some of those sanitary lines are in, they can act as
Right.
a trench.
And, jumping back to, the manhole inspections that were done, I think it was $230,000 worth of work identified in there, which includes grouting manholes and grouting pipe seals and grouting pipe troughs, which were identified as leaking. So that's consistent with the groundwater component of this study.
And we did not do any televising at all, correct?
No, that actually is a recommendation out of both of these reports, especially since, it's believed that there's more flow during the bigger rains. We didn't get to monitor a real large rain during the study, so we don't know if, some pumps just never kicked on during this metering period.
Right.
But also televising is just, it's good housekeeping for you guys to get a, good look at those pipes, be able to assess them, rank them, with NASCO scoring so that you can have kind of a priority list of, hey, some of these pipes were ranked really high in need of repair, other ones are in good condition. All of that can be, determined with a CCTV inspection program.
One of the questions I would want to look at, just in the section in that basin number 2, is if it's clay tile or not, and if it is, were those connections factory tees or were they actually chop-ins?
Right.
Because chop-ins, you're going to get all kinds of groundwater.
Right, a lot more groundwater from a break-in connection, correct?
Yep.
Yep. Flipping to page 5, we have a couple tables here. The first table shows basically scouring velocities at your meter locations. So meters 1 and 2 had pretty low velocities and therefore could develop some ragging, some, deposits at those locations. So those are recommended for a preventative maintenance jetting list. Basin 3 did have pretty good velocities there, and there was no issue with slow flow at that site. So that's also very interesting. I found that is right upstream of the lift station that it had good velocities there. We've seen sometimes right at the lift stations there's not much slope to the pipes and there's slow velocities, and there could even be backing up from the lift station cycles into the sewer mains, but we did not see that here in the flow data. Table 4 just looks at dry weather and wet weather depth to diameter ratios. So we did get a spike in basin 1 that was above the crown of the pipe. It wasn't backing up though, it was handling the flow, and it almost appeared like the spike it wasn't due to rainfall, but it was happening like every so often, like once a month there would be a spike, different size spike, but it was almost just a short 5-minute, 10-minute duration, and then it was gone. That's what this first line on basin 1 is an indication of, that it was at 166% of the pipe capacity. But again, it wasn't backing up. It wasn't it was slightly surcharge over the crown of the pipe, but the positive flow was maintained the whole time. It wasn't backing up.
Laundry day.
Yeah, somebody draining a pool, something like that. But the fact that we saw it at 3 or 4 different instances through the period was like, I was looking to see if there was an industrial component, just on Google Earth, looking at the parcels there. I didn't see anything that jumped out as a large water user in that area, though.
We don't have any filtration over there for backwash or anything like that, nothing. So, okay.
All right. Moving on to page 6, looking at the graphic up top shows the depth to diameter ratios again. Again, everything was pretty well within the capacities of the pipe there, so no real problems with capacity other than that one event that I mentioned. And moving into the wet weather analysis, so we typically look at a few different components of the wet weather analysis. We look at the peaking factor to see what is the overall peak of the wet weather flow compared to the average flow, and that can tell you, severity. It could also tell you, is there a large component of inflow sources out there? So generally, anything over a 4 peaking factor means that there's, enough inflow sources out there to go after removing those. We had on basins 3 and 2 less than a 4. So you can see those are shaded as green in the report. Really not that bad from the storms that we had during the study. Again, we didn't get a real strong rain event. Everything that we had was less than a 1-year recurrence interval. So we might have had, some 3-month events, maybe up to a 6-month event, but nothing that reached that 1-year recurrence interval. Sometimes that's the point where the system gets really stressed and you can start to see, a more significant inflow and infiltration response.
And with that, so when you hit those peaks, was it typically so many hours after the rainfall? Was it, because sometimes that shows more of infiltration,
Sure.
groundwater.
Yeah.
Compared to
So-
sump pumps or things like that.
Yeah, no, the peaking factor is generally almost instantaneous. So the peaking factor response, usually that's the inflow sources, that's the quick, fast-acting response from the rainfall. The next section we're going to get into talks more about that long, extended infiltration response. That's what we look at volumetrically, because it's important to know that, this basin spiked up real quick, but if it drops real quick too, you may not even have an issue. There could be a couple inflow sources, but it may not be that much volume for treatment or billing purposes. But if you've got something that comes up and it takes 2 weeks before it comes back down to normal,
Right.
You've got that whole period of elevated flow that adds up to a large volume of flow that you're going to be paying for treatment costs, for pumping costs, electrical costs at the lift station, billing, et cetera. So we look at both of those components as part of the wet weather study. And that's bringing us to that next piece. If we flip to page 7, we looked at the volumetric analysis and then ranked the basins by volumetric. So the first volumetric piece was looking at the net rainfall-derived infiltration and inflow in million gallons per inch of rainfall. So again, you see basin 1 was kind of the leader of the pack there at 70,000 gallons per day. And 3 and 2 had less. Looking at it from gallons per linear foot of rainfall, again, basin 1, we were at right around 3 gallons per linear foot of pipe per 1-inch rainfall. So we kind of looked at, you could have a large flow from one basin, but that basin could be bigger. So then we look at this one to break it up over the actual length of pipe in that basin as well. And basin 1 was still the highest. We also will use the basins that were delineated and look at percent rainfall capture. So of that same 1-inch rainfall, we'll calculate the volume of a 1-inch rainfall over that whole entire area, and then calculate how much of that was identified as rainfall-derived infiltration and inflow. Typically, anything over 5% is considered significant. Everything was well below that. We were at 1% and under for all 3 of those basins. Yeah, there's in italics below each table, there's kind of the threshold for what's considered significant. So all of them were generally speaking under what we would, say is excessive infiltration or, has a large volume of flow coming from these basins. So they were generally okay. Next, we looked at sewer capacity. Another, the depth over diameter ratios were one way of looking at sewer capacity, but we also look at the scatter graphs. All of the basins exhibited enough capacity in there. I thought there was a table in here that showed that, but I'm not seeing that. So most of the dry weather capacities were in the 20 to 40% range, I want to say.
I've got a quick question. From your page 7 analysis,
Yes.
you're showing basin 1, basin 1, basin 1 is the troubled, correct?
Yeah, it has the most volume of infiltration and inflow, yes.
Then I go to page 4,
Yep.
and it doesn't seem to be reflecting that.
So the difference is page 4 is your dry weather groundwater infiltration. So pipes will leak 365 days a year. Middle of summer, we're going out to barbecue on the 4th of July. There's still pipes that are leaking because they're underneath that groundwater table and they're getting significant groundwater infiltration. What we're looking at on page 7 is the infiltration that's identified during a rainfall event. So that rainfall event then
So you're-
sets
you're-
off other sources that don't activate during the dry weather.
So you're looking at your dry flow, whatever that flow is.
Mm-hmm.
And then when we do get the rain event, that's what you're saying is reflect on page 7.
Correct, yeah.
It's going from, it's elevated already, and it's going from this point, and then when it rains, it's spiking up, is what.
So
page-
likely, when it rains, the groundwater table is raising up as well, so we're getting more infiltration sources than during dry weather, plus you're also getting the inflow sources from the surface water.
Would it be fair to say that page 4 is more so like underground infrastructure, and then page 7 is more like your surface level manhole covers, things like that?
So page 4 is definitely underground infrastructure. You're talking, the laterals and pipes, probably at the deepest points within the system,
Right.
and that's where your groundwater is, influencing the system the most.
Yeah, yeah.
Page 7 is what happens when it rains. So
More on the
everything underneath the surface is the ground is saturated, so it could be leaking, at a 1-foot interval, or it could be at a 12-foot interval. They're all subject to that infiltration at that point.
Got you.
Does that help to answer that question? Okay. Jumping ahead to page 8, we have kind of just a summary, basically what we just talked about. Peaking factors, basin 1 had the largest, volumetric. Basin 1, again, had the most volume from all 3 different ways of looking at the volumetric analysis. Groundwater infiltration was high in basins 2, and basin 1 was a little bit above that marginal threshold. Capacity analysis, all meters showed sufficient capacity during this study. That doesn't mean we get a 5-year rain event, everything could be underwater, but we did not get any of those during the study. So everything that we saw, there was still capacity in the system. Jumping to page 9, next steps recommended. Well, the first 2, A and B, smoke testing and manhole inspections, you guys have already completed those. So that would just be typical of, the flow monitoring study. That would be what would be recommended, especially for, the 5 peaking factor in basin 1, and then all those infiltration sources that were identified through the volumetric analysis. Really, the next step would be cleaning and televising, which we talked about. That's going to help to identify a lot of those additional infiltration sources, whether they be, activating 365 days a year as those groundwater infiltration sources, or whether they're, more due to wet weather events and, those breaking connections that John was mentioning earlier. So we feel that's an important next step. 2 of the basins, and that cleaning and televising, works for, all levels, the groundwater infiltration as well as the wet weather infiltration, as well as the preventive maintenance jetting too. So those locations 1 and 2 that were not completely self-cleansing, important to get those, or at least check on those, once every 6 months, make sure there's not, debris that's starting to build up at those sites, but a cleaning program would address those as well. And then capacity assessment, at this time, there was no issues with the capacity at those 3 locations. The appendices have maps kind of showing the color coding rankings for peaking factor, volumetric analysis. There's also some of the flow graphs, the flow charts in there, the site sheets for where the meters were installed and the location of the sensors within the pipes. I know it's a ton of information here, so, if you guys want to look at the report and, ask Dave questions or ask me questions, I'm happy to follow up with you guys and, answer any additional questions on either one of these studies or on next steps for these areas as well.
You didn't by chance, whether it was done in the initial, where you looked at manholes or any manholes that were in low-lying areas that may become flooded or water, over the top?
So I could go back and look through the data because we do measure if it's above grade or below grade.
Or even if it's above grade, if there's, I don't know, if we have certain areas that may,
If it were in like a,
close to a detention
ditch
or
or
something like that, or a
something.
ditch or something, then
Yeah.
now, once that ditch fills, that manhole's underwater.
yeah, generally the cover recommendations for those pick holes or those covers that don't have a gasket underneath them anymore, generally that's going to address those locations, but I could follow up and just, take another look through the data set
Yeah,
and make
just-
sure.
Because those are some obvious things that can be taken care of pretty quickly.
Yeah, I agree.
And the reason I say that, I'm looking on in some of the, in Appendix 1, it shows a manhole here that looks like it's out in the middle of a field somewhere with a ditch real close to it. It's SA 30-019 was the site. And it was just,
On which page of the appendix?
is there a page number on this?
Yeah.
I don't think so. At the top, it says, looks like,
in the- Yep.
Okay, second page in appendix 2. Oh, I'm looking at
Appendix 2 or Appendix 1?
appendix 3.
It's 2. Well, now you're looking at it.
Oh, yeah, Appendix 2, excuse me, yep. Is it? Okay. And it'd probably be a question for Mike. I don't know if that area gets inundated with water or not, heavy rains or. I'm looking at that one right there.
Oh.
'Cause it
okay,
almost
you're
looks like
looking
there's a
at- I'm
ditch.
looking at the different
Almost looks like
report.
there's a ditch back there, and I didn't know
Yeah.
if this by chance
Yeah,
gets,
I'm looking at this one, I mean, you could see that.
Yeah, that-
Right there is probably subject to
yep,
flooding as well, which would have been called out for, probably a frame seal defect.
right.
Yeah, okay. I jumped back to the other report, sorry about that. Okay. Yeah, so all of the manhole data, we've got all that, in a large spreadsheet collected from the database. It was downloaded, so we can quickly sort distance above or below grade and find any of those. Also, the photos will help to look at those, but
Right. Okay. Anybody else on the board have questions?
Nope.
Mike, any questions? Okay, I appreciate the report and the explanation, and I'm sure we'll be in touch in the future.
okay. Thanks for having me here.
Thank you.
Yep.
Okay, next on the agenda is new and old business. Item A, consider approval for a professional services agreement with Baker Tilly for the, serve as the financial advisor for the sanitary district for year 2025. Looking for a motion to approve.
So moved.
I'll second.
Motion made and second to approve professional services to Baker and Tilly for the 2025 advisor for the sanitary district. All those in favor say aye.
Aye.
All opposed? Motion carried. Item B, once again, this, I would like to see this deferred along with item C till we get some of the, there's some questions on the contract language for those agreements. That first agreement is with Robinson Engineering to serve as engineers for the sanitary district for year 2025. And item C is services agreement with McAlpine Consulting for the secondary engineer for the sanitary district in 2025. I look for a motion to defer items B and C until the next meeting in February.
I'll make that motion.
Motion made, second.
I will second.
Motion made and second to defer items B and C. All those in favor say aye.
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 All those opposed? Motion carried. Item D, consider a write-off for unpaid sewer charges and penalties in the amount of $301.21. Looking for a motion to approve.
So moved.
Looking
I'll
for-
second.
Motion made and second. Under the question. All those in favor say aye.
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 All opposed? Motion carried. Item E, sewer and landscape credit totaling $893.62. Looking for a motion to approve the sewer and landscape credits totaling $893.62.
I just have one question,
Yes.
and this would be more for Mike. On the Dukes Turner one, the landscape, or basically the sewer credit, they had a leak alarm for 20 days, according to this printout. Is that addressed somehow? I mean, they were blowing water for 20 days. How do we get in touch with them?
I'm not sure. I
Okay.
wasn't aware of that. I know when we read meters, then we know.
Yeah, it says the leak alarm shows, 20 days of a full-blown alarm. I was just curious, in the homeowner's interest,
Yeah,
we
I don't.
need to get in touch with them.
Like, and I don't know if you know this, so does the water billing clerk, does she receive those alarms and then does she make phone calls to those residents, or is it up to the resident to sign up to get that information sent to them that they have a leak going on somewhere?
That I'm not sure.
Now they have that new app.
Well, that's what I'm talking
I
about.
saw the new app, but in the interest of looking out for our homeowners, they're on the hook for this water.
I did see something about a new app that you can log in and see your
Right.
usage. So it might encourage people to sign up and take advantage of that app.
Right.
And I do understand why they're asking for the credit. They still had to pay their water portion of it.
Exactly. And
It's
then,
just that this
the
water
interest-
ran on the outside and it actually didn't go into the sewer system.
yeah, I mean, if I was that homeowner, boy, I'd appreciate a call, and according to their letter, they were home, they were ill. So, it'd be different if they're in Aruba or something, but,
Was that outside Silcock or something? I'm not aware of what it was.
It kind of looked
Yeah.
that way.
Frozen busted and,
Yeah.
yeah, and the app sounds like a wonderful thing. Maybe we really need to push that.
Yeah, it says around the end of November that we had a break in our hose and the water was on. So they just forgot to disconnect it and it froze and it broke pretty much.
Yeah, no. That's this one.
Oh, I'm looking at a different one. now.
Yeah,
Yeah, the hose was running into an open field.
yeah, these people do.
Well, then this people had the same thing.
Yeah,
Oh, there you
yeah,
go.
they still have a $600 water bill,
Right.
so, okay, Mike, thank you.
Anything else under the question? I'm not sure if we had a motion on this or not.
I'll make the motion to approve.
I will second.
Motion made and second to approve the sewer and landscape credit totaling $893.62. All those in favor say aye.
Aye.
All opposed? Motion carried. Payment of bills. Item A, accounts payable voucher dated January 15th, 2025, representing payment for payroll, supplies, services, and equipment rendering to the sanitary district in a combined total of $18,164.99. Looking for a motion to approve.
So moved.
I'll second.
Motion made and second. Under the question, all those favoring say aye.
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 All opposed, motion carried. Item number B, accounts payable voucher dated January 15th, 2025, representing payment, payroll, supplies, services, equipment rendered to the wastewater utility for the combined total of $480,895.58. Looking for a motion to approve.
I'll make that motion.
I'll second.
Motion made and seconded. Under the question, all those in favor say aye.
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 All opposed? Motion approved. Reports and correspondence. Robinson Engineering, any project updates?
Thank you, Mr. President. The Lantern Woods I&I study is our only current sanitary project, so no further updates.
Okay. Mike, Public Works?
I just want to thank Robinson for doing that, and we'll take everything under advisement, and we'll go from there, see if we can get some of this done in the spring.
Sounds great. Town manager's not here. Anything from the board members under general discussion? We have none. Any comments from the public? Okay, there are no comments. Looking for a motion to adjourn.
Like that motion?
I will second.
Motion made and second to adjourn the St. John Sanitary District meeting for Wednesday, January 15th, 2025.